In this video, we are going to be finding the zeros of this fourth degree polynomial. In other words, we will be solving the equation of this polynomial equal to 0. Now, before I get into this, just generally speaking, let's talk about the different possibilities, scenarios we could run into working with a fourth degree polynomial. So once we have the polynomial factored completely, there's a few different things that could happen. It could happen that all 4 of our zeros are rational. And if this happens, the problem works out for us very nicely because we would find all 4 of those rational zeros when we ran the rational zeros test. It's also a possibility, remember that irrational zeros come in conjugate pairs. So it is possible that we have an irrational zero and an irrational zero here, and that the first two were rational. Now, if this happens, we would find the first two from the rational zeros test. We could then divide out by those two to be left with this, which would have been our missing quadratic. And then we could use the quadratic formula to find those last two. Similar to the last case, it could be that the first two zeros are rational and that we find them from using the rational zeros test, and that the last two zeros, again in a conjugate pair, are imaginary. So any of these 4 cases we should be able to work through pretty simply by starting with the rational zeros test and then using division to find that missing quadratic and find those last two irrational or imaginary zeros. Now, this problem in particular and a similar problem on your homework, it's neither one of these cases. It's a little bit different. It's more like the second one, but these two rational zeros here are the same zero. So let's look at how that works out when we go through this problem. So I'm going to start by listing divisors of my constant term. The numbers that go into 20 are plus or minus 1, plus or minus 20, plus or minus 2 and 10, plus or minus 4 and 5. And then I will list divisors of my leading coefficient, which is only 1. So I would only have plus or minus 1. And so my list of possible rational zeros would be the same list as my divisors of 20, because I would take the numbers in the first list and I would divide all of them by plus or minus 1, and we would only get the same list back. Now, this is the point where we would go to a table and plug these numbers in and see which of these are actual zeros. And the only zero that we would find in a table is 2. And that can be confirmed by looking at a graph. Here I have a graph of this polynomial function, and you can see right there on the graph that we do have a 0 at 2. So at this point, let's make some observations. When we talk about this polynomial being factored, because 2 is a 0, we know that x minus 2 is also a factor. Now we're missing 3 different factors. Now remember that imaginary and irrational zeros come in pairs. So what is possible is that these last two are both an irrational pair of zeros. It's also possible that these last two are an imaginary pair of zeros. But that still leaves the question about what about this one here? It's not possible that all 3 of these are irrational or that all 3 of these are imaginary, because those zeros come in pairs, so there would always be an even number of them. So it must be the case that this 0 here that we still don't have has to also be a rational 0. Well, we've already found the only rational 0, and it was 2. So it must be that this is also x minus 2. So in other words, I'm saying that x minus 2 is a 0 that shows up with multiplicity 2, and then we would still have some missing quadratic factor. Now, I hope that when you look at the graph of that polynomial, you can verify and confirm that, because when you look at the graph only touches the x-axis at 2. It doesn't cross through the x-axis at 2. So the fact that that graph is touching the x-axis at 2 implies that this 0 has even multiplicity. So I know that that has to show up with 2. So at this point now, I can start going through my division. So I'm going to divide out by the first factor of x minus 2. I'm going to divide out by this first factor here of x minus 2. I'll use synthetic division. I'm going to line up my coefficients from my polynomial. I do expect that our remainder is 0 because this should be a factor. So I'll bring down the 1. 1 times 2 is 2. Add to get negative 6. Multiply to get negative 12. Add to get 13. Multiply to get 26. Add to get negative 10. Multiply to get negative 20. And we get a remainder of 0. Good. So now at this point, what this tells us, I'll call the original polynomial that we started with, I'll call that p of x. So at this point, we know that p of x does have a factor of x minus 2. And the cubic factor that we're left with from these coefficients is 1x cubed minus 6x squared plus 13x minus 10. Now, what we've said earlier is that as we continue to break this down, it must be that the x minus 2 shows up again within that. And then there's the missing quadratic that we still have not found yet. So what I'm going to do now is I'm going to divide this cubic polynomial again by x minus 2. So I'm putting 2 in the box again. Once I get a remainder of 0, that confirms that 2 did show up as a 0 with multiplicity 2. And as you can see, I am getting a remainder of 0 again. So now, remember, this was cubic. We started with x to the 4th. We did a division one time and got x to the 3rd. This is still that x to the 3rd down here, and now we're at x squared. So now we know that our function p of x has x minus 2 showing up as a factor twice, and the quadratic factor that shows up with it coming from these coefficients is that right there. So far in our list of zeros, we still only have 2. It just showed up twice. To get the rest of our zeros, we're going to take this quadratic and we're going to use the quadratic formula on it, which tells us that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Word of caution from some of the conversations I've had with you all, after you do division one time right here and get this answer there, you're not ready to use the quadratic formula because that's not quadratic, that's cubic. You started with a 4th degree, did a division, and got a 3rd degree, so you have cubic. So you could not use the quadratic formula up there. Okay, so now going back to my quadratic formula, b in this case is negative 4. Just looking at these coefficients here. So we have negative 4 plus or minus the square root of negative 4 squared. That does need to be in parentheses when you square a negative number. Times 4ac all over 2a. So we have a positive 4 plus or minus the square root of 16 minus 20 over 2. So that is 4 plus or minus the square root of negative 4 over 2. And the square root of negative 4 is 2i. And now all of these are divisible by 2, leaving us with 2 plus or minus I. So our zeros are 2, 2 plus I, and 2 minus I. And if we were to completely factor the polynomial, we know that the 0 of 2 shows up with multiplicity 2. And our remaining 2 zeros were 2 plus I and 2 minus I. So the whole takeaway I want you to take from this video is that if you start with a 4th degree polynomial and you run the rational zeros test and you only find 1 0, it has to be the case. So if you're missing 3 factors at this point, it has to be the case that that one rational zero showed up twice, showed up with multiplicity 2. Because the other 2 things that you're missing come in a pair. So they couldn't account for this third one right here too. And remember, that can be confirmed on the graph, because when you see the graph come into that 0 at 2 and only touch the x-axis, that automatically implies that this factor has an even multiplicity.